Okay, so this is section 9.6. It's our last section for conics. We're going to talk about solving a system of equations containing first or second degree equations in two variables. And we're going to talk about how to identify a conic from its equation. Now, in the past with this, we're going to actually talk about this one first with our first few videos. And I'll hop right into it after this. But we'll talk about this later, so before I get into it, we'll discuss it as I'm going over those slides. But solving a system, we should know kind of what that is. But this first part, we used to have to get it into y equals and try and figure out what the picture was and go from there. But now we're going to talk about how I can actually look at an equation and know exactly what it is. And so we're going to talk about those specific details. Okay, so you can see here I have this list of information. I have this column here that says, the different type of conics that we have right here. Here's our standard form, which we've seen before. These are the ones that when it's in this format, we have to complete the square to see what it looks like. Now, the coefficients of these terms tell us the type of shape. So just to run through these real quick, if it's an ellipse, A and C are different, and they're both positive. If it's a circle, A and C are equal to each other. Parabola, only one squared variable, and if it's a hyperbola, A and C are being subtracted. So if we go ahead and look at this, and I'll do a couple quick examples where we just kind of put numbers and just kind of work with the equations that we've kind of talked about. So if I have, for example, 4x squared plus 4y squared is equal to 36, let's say. Notice that this guy is our A and this guy is our C. Now, what we could do with this format, and I'm not putting any of this junk here because if you look at all of this, that really doesn't matter. It really doesn't matter what those numbers are for the most part. That just really is the shape, if you will, how it's shifted left or right or up or down. So all we care about is these coefficients in front of the x squared and the y squared. So okay, well I know an ellipse always is equal to 1. So if I go ahead and divide everything by 36, that gives me the standard format for an ellipse. Okay, but what happens here is I have my a squared is equal to my b squared. So a is equal to 3 and b is equal to 3. So if I was to graph this, it's centered at the origin, which means that I'm going to go from the origin, I'm going to go up 3 and right 3. Well, the distance from the center is the same. So, well, what kind of shape is that? That's a circle. So when these two guys are the same, I'm going to get, well, an ellipse. An ellipse is a circle, but not all the time. Okay? So an ellipse is a circle when a squared and b squared are equal to each other. So when the a and the c, or those coefficients, are equal to each other, we're dealing with a circle. When they're different, they're going to be an ellipse because these distances right here would be different. And we're going to go through a couple different examples, and I'll kind of walk through maybe some generic examples with numbers so we can discuss and you guys can see, oh, okay, it's got to be this, it's got to be that shape or this shape. But the idea is primarily with all the shapes except for a parabola, we're just looking at these three things. And those three things right here that I just circled, so the A, whether it's positive, or the C, is going to tell us what kind of shape it is.